Hello, welcome to the fifth video in our series of demonstration videos for the VPAT tool. In this video, we're going to review the capacity planning function. Specifically, we're going to look at growth at the LPAR level and plotting it and projecting it. So let's start by starting at the basic capacity planning screen. And as we've seen in prior demonstration videos, we're going to read in some predefined screen data, which will save us some time. And here we can see that we've loaded some definitions. Now, this file here came from our original extract process way back when. So this is our LPAR data. And if we had multiple LPARs or multiple KECs, and we've had multiple EDF files or multiple RMF data input that we've processed through the extract process, we could have multiple report files specified here. And in the end, we would be allowed to select or combine multiple LPARs from each of the systems that we've provided data for and model that out in our capacity requirements. For now, we're just going to leave this one file here. This MIPS field, we're going to leave blank for now. This is primarily going to be used if you're doing zip capacity planning. And we're going to use GP engines, and we're going to leave this blank, and the system will drive us as we need to. Now, on the bottom, these are our target systems that we're going to project our capacity requirement against. So we have a 710 and a 711, and I think we're going to add in the 712 box now. So we're going to do that. We're going to click on an empty row, and we're going to click on the M button, and we're going to find our 2964 712, and we're simply going to double click on it. And now this shows up in our row, and we're going to select it to be part of our result modeling. Now, of interest here, we can overlay these MIPS numbers in this field for any values we like. So if we ran ZPCR, we might have a more accurate MIPS value for the 712 or the 711, and we can simply overtype them here. We could simply make this, instead of 30, we can make this 31. Now, if we hit enter, that merely takes it. So we can take that back out, and we can go back to our default value. Now on the right here, we have some graphing titles, but on the right here, we have the ability to apply growth at year 1, 2, 3, 4, and 5. And this will be compounded growth. So if we specify 10% growth in our first year and we specify 10% growth in our second year, that 10% year 2 growth is compounded on after the 10% growth in year 1. So to start the process, we're going to click start here, and this is going to take us through the basic capacity planning functions. Now, the first thing we're going to see is something that should be familiar if you've seen earlier videos, and this is our VMIPS table. And for each time that the configuration varied during the observation period, the observation data that's in this file over here, we would have a row in this file here that would represent each model change. And we would have the opportunity to change the MIPS value if we wanted, again, to adhere to ZPCR. To change the MIPS value, we merely click on the field, and we're given an opportunity to change to new MIPS. When you change any individual one, it will change it and be in effect until the next model change, and you'll have to go through each one. Since we've only had one model, and this is a basic demonstration, we're going to leave all the MIPS values alone. So we're going to click return here. And now we would see that we can actually select which LPARs we want to include for our charting and our analysis. Now, as we talked here, these are the LPARs that are contained in this initial report file. If we had other report files that were specified in here, say from other KECs that had other LPARs on them, they would all appear in this list, and we can manually select or deselect which LPARs we want to include in our final modeling. In addition to, as we earlier showed, we're going to apply growth at 10% first year and 10% at year 2. We can also have a different opportunity to apply growth, and this lets us apply growth at the individual LPAR level by just specifying a change at this level here. For our initial demonstration, we're going to leave this alone. In our next video, we are going to go and show how we can modify LPAR and workload level capacity planning numbers. But for now, we're going to just demonstrate basic KEC level growth and charting. So we're going to say OK here, and we're going to move forward. And now we can actually begin to see some more information about what sort of information we're going to show here. This is our anticipated weighting. This is our weight we're applying on the system, the LPAR weighting. And this does add to 1,000. Now, if you had more LPARs, they would show up in here, and VPAT would be showing you some sort of aggregated weight numbers here that you have the ability to modify and change to see results as we project our capacities against our targets. So we're going to start with a MIPS display here. And this is going to take the values that are in our other tables, and it's going to show us how our capacity projects against future models. So we're going to click MIPS here, and we're going to see that we get a chart now that shows us our basic organic underlying CPU utilization on our existing machine, and we get a series of target lines. Now let's zoom in a little more. Let's zoom in on this familiar date, February 12th, to see a little more details. What we can see is we can see our current utilization numbers, which are in the area chart at the bottom, showing by LPAR. And we can see our current actual capacity line right here, which matches up with our current actual machine that we've specified from the capacity planning model, which is the 2964-710. So we can see that we touch 100% here, we touch almost 100% back here, and we definitely saturated 100% during this point in time on our current machine. Now, VPAT has taken 10% on year one and given us the red line. So what it has done here is it's actually plotted out a 10% increase, and it's showing us how our capacity may align against some future models here. So by looking at this here, our 10% growth in year one is actually going to push us slightly beyond the capacity of the 711, such that we may need to go to the 712 to satisfy our CPU demand that we're going to anticipate here based on growth. So we can easily at a glance here determine which machine is potentially applicable at our different growth scenarios looking forward in the future. So this is going to help us make decisions more accurately. Now, if we go back here, we can also click into utilization. And what this is going to do is this is going to take our base utilization, our underlying organic usage, and it's going to project it against whatever target machine we pick. So if we pick utilization and we click our 2964-710, we're going to see here that we're going to zoom in here on the 12th again. And what we're going to see here is that we have our line here now showing what our underlying organic usage is here, and we've got a 10% projection line. So basically what we can see on this, when we look at it in detail, specifically at this point in time, is that our saturation at 100% is going to grow. We're going to have a longer period of time where we sit at 100% capacity if we apply 10% on our current machine and keep it at a 2964-710. If we return back, we can pick the 711, and we can actually look at utilization targeted against that. We'll zoom into the 12th again, and we can now see that we still have a period of 100%, and that's what we saw earlier, that we were going to exceed the capacity of the 711. We can also see that if we stay on the 711, that we're going to have an even longer elongation period at 100% when we get to year two growth. So we're seeing the individual machines plotted with our base growth, our base usage here, and our projections at the top. We can also plot against the 712, looking at utilization projections. Again, utilization is projecting everything against 100%. So we're going to see here now that our 100% period is somewhat comparable to where we are on the 710 now. This is our current utilization. We know that we hit 100% here, and we know that, well, in year two with 10% growth, that the 712 might give us a similar performance pattern where we see points in time where we touch 100%. And perceptively, this looks like about the same amount of time. So that's the functionality that we can get out of the basic capacity planning functions using the LPAR and CEC level growth functions here. Now, if we plot against 100% and plot against all of our processors, this is a slightly busier view. And when we look at this here, what this is actually telling us is it's only showing us our base usage. So it's not showing us our 10% and our 20% growth. We'll see more usage of this chart in our next video when we go into LPAR and workload level growth management. So for the time being, this ends our 5th video where you can see how to do basic capacity planning. Please stay tuned for our next video. Thanks very much.